Hello, I hope you had a good Easter, and now we're back and we are carrying on now with area, perimeter and volume. So for level 2, a lot of this is about circles, so we did this not too long ago. I'm going to make sure that we understand surface area, the parts of a circle, then these words circumference, and we're going to look at volume as well. So apologies if this is quite long, but we are just revising quite a big topic. Okay, so first of all, there is some assumed knowledge from level 1. So I haven't gone through this in this video because we have to assume that you know it already. So this is the perimeter, making sure you understand that that's the distance around the shape, knowing what area is, the space inside the shape, and also the formulas for them. So to work out the area of a square rectangle, length times width, and for a triangle, I do actually cover that one in this video. And the volume of a shape, how much space a 3D shape, like a cube, imagine a box, a cardboard box, the space inside it, length times width times depth. If you want a refresher of these, I've got these 2 videos down here. So this first one, you can copy that out or actually search using search for this in YouTube. It'll go through these in more details, and then if you want to further carry on with that, there are some practice revision exam type questions, again because it assumes you know how to do those at level 2. I know it's having to spend more time on maths, but it's well worth doing. Right, so surface area. So imagine you have a 3D shape, in this case a cube. So I'm going to draw a little cube. It's my delivery box from Amazon, and I've now flattened it out, and there's my net. So what I want to actually work out, what is the total area of all of these squares. So I'm going to work out the area of one square, which, as you know, is length times width. So we've only got one dimension here. We've got a side of 5 centimeters. Well, in a square, all of the sides are the same, so that's 5 centimeters as well. I don't know why my pen's doing these weird straight lines. You're just going to have to ignore them. So the area of one square is actually 5 times 5, which equals 25 centimeters squared. But what's the total surface area? Well, there's 1, 2, 3, 4, 5, 6 squares. So 25 times 6 is 150 centimeters squared. Okay, you just need to know that a surface area is like the total outside of a 3D shape. Right, since we're going to be doing some circles, we need to be able to calculate with pi. So this is quite difficult when you're at home and if you don't have a scientific calculator. Now a lot of you might do from your GCSE days, or they could be stuffed somewhere hidden out of sight. Your smartphones should have a scientific calculator on. If you open your calculator app and turn it to its side, you should get one. Otherwise, I did find a good website here. If you want to go to that website, there's a good on-screen calculator. That might be quite useful if you've got another device in the house and you want to have the calculator on one and then view the documents with another. Let's start with making sure you remember the different parts of a circle. So the diameter is the length that runs right across the circle. So I've done it from left to right here, but it could go like that. It could be a random. It could be there. It could go. So it usually it goes through the center. Didn't draw that very well, but it could be any of those. The radius is exactly half the amount of diameter. It goes from the middle to the outer edge. So from the middle, I could draw the radius like that, or like that, or like that, or like that, or like that. It's always half of the diameter. And last but not least is the circumference. This is the distance. Oh, Come on, pen. I have been having major pen issues. Right. This is the distance all the way around the circle. Oh, what a terrible circle. Much easier on a whiteboard. Yeah, lost my train of thought there. So yes, the distance all the way around the circle. Any other shape, we would call it the perimeter, but just because it's a circle, it's got a special name. Sorry, circumference. Let's calculate circumference. So here's the formula that you would be expected to know. Pi d, or pi times diameter. So on your calculator, we want to find the pi button. So before we carry on, if you're using a calculator that doesn't have pi, you can also use 3.142. So that's an option. Anyway, let's carry on. So pi times the diameter, which in this case is 5, gives us, I've just put 3. I know that's wrong just by looking at it. There we go. So 15. I'm going to do all of these to one decimal place. Any exam questions would tell you. And this is centimeters. So remember, this is all the way around. If I was to unravel that circle and lay it like a long piece of string, it would be 15.7 centimeters. Sorry, I just had to cough there. I hope you didn't hear it. Let's try another one. I think there's another one on this slide. Let's just get rid of all of these. Come on. Right, come on, pen. Do as you're told. Right. Here's another one. So now I'm going to the distance all the way around this yellow circle on the right hand side. So remember, it's pi times d. So in the calculator, I'm going to put pi in, then times, and what is the diameter? This is a bit tricky. I've not been given the diameter. I've only been given the radius. If I was to carry on that line, so I went all the way to the other edge, now that would be the diameter. And since it started in the middle, the other side will also be 5. So together, that diameter is 10 centimeters. So pi times 10, we don't really need the calculator for that, do we? Just times it by 10, 31.4, just do it to one decimal place, and it's just centimeters. There's no squared or anything yet because that's area. This is the distance all the way around the edge. Here's a problem solving thing on circumference. So this is find the total distance around this shape. So around this shape is a semicircle and this line across the bottom. So we want to find the total distance. There is no direct formula for finding half of the circumference. What we can do is find the total circumference all the way around. So we'd have to imagine, oh, something funny has happened to my computer then, all the way around here, and then I'll just divide it by 2, so I only get half of it. So let's do that. So pi times the diameter is 16. So pi times 16 is 50.265, and it carries on, but I'm just going to leave a few numbers there, and if I need to round, I'll do it at the end. So that's a full circle, but I only want half of it, so I'm going to divide it by 2, which gives you 25.1327 blah blah blah. So now I'm going to colour in. This is the bit I've got. I've just found the distance of this bit here. I still need to add this extra blue line in, which is 16 meters. So I'm going to add these together. So I've got 41.1327. I'm just going to round it. 41.1, and it's meters. Perhaps it's a weird running track. Okay, let's move on to area. So area is pi r squared. Pi times r squared. So here's our first of our two examples. This circle here, this blue shaded circle, let's do pi times, what is r? I don't have the radius, what I have is the diameter. The radius would be half that amount just from the middle. So half of that is 5, and then we need to square it as well. When you're using a squared button on the calculator, you need to find the button that looks like this, x squared, or it might be like a curly x with a squared. Or you could just do 5 times 5, which is 25 instead. So let's calculate that into one decimal place. 78.5 centimeters, and now I need a squared because this area, this is inside this shape, is 78.5 centimeters squared. Okay. By the way, none of these drawings are to scale, obviously, because the circle's the same size. Let's try another one. So pi r squared. So pi times, what's the radius? Well, this time we do have the radius, and it's only 2. 2 squared, which, 2 times 2 is 4, so that's not too bad, is it? So that gives us 12.6 meters squared. Let's move on. So we've done area. Now we're going to take a look at the volume of a cylinder. So the volume is the space that can be held inside the shape, inside the 3D shape, sorry. And to work out the volume of cylinder, which you're expected to know, is you need to work out the area of the circle first, and then we times it by the length of the shape. So the area of the circle is this bit on the end. So I've actually drawn that's what the radius looks like. So we're going to find out the area of this circle, which is what we've just done on the page before. So remember, that's pi r squared. So pi times the radius is r, it says r equals 22 squared. I mean, that would be, that's going to be a big number, isn't it? 22 squared. So pi times 22 squared is 484. Altogether is 1,520, and then it's point blah, 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 blah. I'll just keep a few odd. I'm going to round at the end. So that's the area of the circle. But I still need to times it by the length of the prism. So this lovely big number here times 50. Thank goodness it's a calculator question. This is a big number. 76,026.6. That's the nearest one decimal place. And it's millimeters. And this time it's cubed because this is a 3-dimensional shape. Okay. It's a massive number for, compared to like just having 22 and 50 on the diagram. These are millimeters, so they're tiny. It's a small unit of measurement, so you're going to fit a lot inside that shape. I'm going to do one more cylinder, but this time, we're going to do it with no calculator. I've seen this on one of the sample tests, which I thought was a little bit cruel at first, but actually it's not that bad once you get into it. If you don't have a calculator, you have to use a fraction as pi, 22 over 7 or 22 sevenths. If you were to just do 22 divided by 7 in the calculator, it actually equals 3.142. And there's more numbers after that. It is then the closest fraction to the actual number pi. Right, let's do this. So remember, it's the area of the circle, which we're going to deal with first. So the area of the circle, I've drawn the radius on there. We're going to find this area first. So pi r squared. Now we don't have pi, we're replacing that this time with a fraction. So 22 over 7 times the radius is 7 squared. Now this is where it gets interesting, because at first you think, oh my god, what am I going to do with that? Just a quick reminder, 7 squared actually equals 7 times 7. So if I'm going to rewrite this now, 22 over 7 times 7 by 7. You'll notice that there's a lot of 7s in there. Now when you divide by 7 and you times by 7, they actually cancel out. So I can get rid of this one and I can get rid of this one. So what I'm left with is 22 times 7. And if I was to solve that first, I mean, you could go ahead and, do a grid and work it out that way, but I know it actually equals, I'm going to go over here now, it actually equals 154. And then don't forget, I've got to times it by the length of the prism as well, so that's times 100, which fortunately means we just bang on two zeros on the end, giving us 15,400 millimeters cubed. I quite like that one for a fraction. This is the very last one, so we're going to do the volume of a triangular prism. This is a calculated question, although you can do it without. But first of all, we're going to find the area of a triangle. So a bit of a reminder for you. The area of a triangle is base times height divided by 2. That gives you the area of a triangle. So let's do that first. So we're going to solve this little cross section, this little thin slice of a triangle just at the end. So base times height. What is the base? Well, this number 4 here, this is the base. This is the base of the triangle. Then this is a tricky bit. What's the height? Because you've either got the 7, which is sloping, or the 6. The height of a triangle is always the tallest part of the triangle. It's not necessarily the slopey part. So in this case, it's actually 6. So that's how we find the area then. So let's solve that. 24 divided by 2 equals 12. Oh, it's done that funny thing again. 12 centimeters squared. But we've now got to times it by the length of the prism. So that here we are. This is the area of that triangle. We're going to times it by the length. 12 times 12, 144 centimeters, and it's cubed because cubed, it's a volume, it's a 3D shape. Notice that when we were solving the calculation before, it was a squared because that was the area. Then we times it by another size, like another dimension. So now it's become 144 cubed. That's the end of this video. I'm sorry it's a long one, but those are the things that we covered, and that took us about 5 to 6 weeks to do this year. So hence it's quite long. Okay, thank you. There is a second part. Bye.